Hey guys, how's everyone doing? Today we'll be looking at LeetCode problem number 311, the sparse matrix multiplication problem. So to kind of get us started, this is one of the top 50 Facebook problems to solve. And when you actually look at the solutions, it actually doesn't make intuitive sense. So therefore, I was like, why is this problem like so difficult to kind of break down? And as you start to dig in, the main problem is understanding what a sparse matrix is and how the multiplication works. I tried banging my head against all the solutions, all the videos that I saw, and none of them really like made sense unless I just pretty much memorized the solution. And I don't think that's really a great way to go. So I actually came across a solution that is not as, in terms of runtime, not as good as the optimized solution, but it's a lot more intuitive. And under the pressure of coding, let's say you can't remember the optimized solution, this will be a good starting point to at least let the interviewer know that you were able to solve this problem. So let's get started. If you just quickly read the problem, given two sparse matrix A and B, return the result of A and B. You may assume that A's column number is equal to B's row number. So to really quickly annotate this, and by the way, obviously I'm using Safari and I'm using GoodNotes to actually take down notes. I would highly recommend either having a notebook so that you can actually, take down notes so you understand it yourself so you don't have to memorize the solution. Anyway, so let's get started. So this is our input. Our input is 1, comma 0, comma 0, negative 1, comma 0, comma negative 3. And then B is, just to get us kind of started here, 7, comma 0, comma 0, 0, comma 0, comma 0, 0, comma 0, comma 1. All right. What we know about the matrix is this is a 3, or actually, let me actually, yeah, that's fine. So now this is a 2 by 3 matrix, and this is a 3 by 3 matrix. Now, one thing I want to call out to is in the instructions it says you may assume that A's column number is equal to B's row number. So this piece here matches this piece here. So that's an interesting clue here. And one thing that we kind of want to call out to is also that if you just read about how sparse matrix multiplication is supposed to work, it's supposed to be the dot product. So what does that really mean? What that means is, sorry, I had to take a quick sip of water, is that the the resulting matrix, and by the way, we can just kind of, for the time being, because we're not going to code just yet, I'm just going to work specifically on putting the algorithm together, just so that I have a little bit more space. The resulting matrix, which would obviously be C, would actually have the dimensions of it would actually be the row number of A and the column number of B. So that would be basically this. And the values of it, and I'll just quickly, because this is our initialization step, right? The value of the very first element will actually be the multiplication of the first row with the column of B. All right. Now that's very important to remember because that's this one. What about this one, right? So let's just quickly solve this using that thought process. So the first one is, it'll be 7 times 1, 0 times 0, 0 times 0. So that's 7, right? Then the next thing would be that next one is 0. So if you look at this, it's 0. So it'll be 1 times. So now you're looking at the second column, which would be this one, right? That's 0, right? Because it's all zeros here. And the last one will be, again, it's 0 times 1 times 0, 0 times 0, 0 times 1, so that's 0. And I'm just going to quickly fill this and make sure that at least our base understanding makes sense, right? Because that's where we start. And just to quickly erase this, this goes here. And now the second one, -1, so this should be -1 times 7 times 0 times, so this should be -7. This should be 0 and -3, right? So how did we do? Did we actually even get our algo put together, right? So let's quickly take a look at that. And if you take a look at this, and let me actually do that as well. Whoops, give me 1 second. By the way, I'm using the iPad Pro, and it takes a minute to get everything rolling. Let's do that. And if you take a look, yep, our resulting matrix is 7, 0, 0, -7, 0, -3. So that means our solution is correct, which is pretty nice, right? At least we understood the problem, right? So that's a starting point, really. And now let's go ahead and actually put together like a pseudocode. So what does a pseudocode really look like? For our pseudocode, what we'd want to do is, as we already talked about it, right? Is first we want to create a matrix C. So we'll do equals to new. Now, one thing, if you remember, as we talked about, was that the C matrix will actually have the rows of A and the columns of B. So we'll just do A dot length. Right? Now, instead of traversing the other two matrices, we will actually traverse the resultant matrix and add the results as we go along. So, and by the way, this is just quick pseudocode, so just keep in mind of that. And one other thing, so just to make, yeah, just be careful with matrices, like traversals. Try to use int if you can. Whoops. So now we traversed it, but now we actually need to do the multiplication, right? How are we going to be figuring out that we multiply the top row with the side row and then set the resultant in the specific location, right? Because guess what? It's not going to be that straightforward. You need to do another form of traversal to be able to do that, because this is just the pointer to where the array is. Well, you actually have been, there was one key thing in the problem that it mentioned, saying that the columns of A will match the rows of B, right? That actually gives you your limit of how we need to basically navigate through the matrix, right? So what you can do is we'll put another for loop into length, which goes all the way to whoops, a dot a of 0 dot length, right? Because that's the column length, right? Temp sum. Oh, by the way, just do that as well. C of RC equals, actually, and we'll do plus equals to A of. Now, how are we going to figure out that this is the piece we need to traverse, right? And we actually have that, because guess what? If you look at our response array, right? And let me just think about this for a second, because we would need, yeah, so that makes sense. So R, because of we're using the base level R, length multiplied by B of, because this is the row, right, of I believe it should be, just kind of validating, is C. All right, and that's it. That should solve our problem. So, and then obviously return C, right? So why don't we go ahead and code this and see if this actually works, and we can go from there. All right, see you guys in LeetCode. All right, guys, why don't we go ahead and solve this problem? So sparse matrix multiplication. I'm just gonna fix a few things. First things first, it's gotta be Java. Let's go ahead and solve this issue. So, whoops. I don't know why I did that. It's interesting. All right, whatever. A little bit of defensive programming, you know. So first things first, let's create a response. I know I named it C in my breakdown video, but it's probably better if we name it like an actual response. Like mentioned before, you'd want the length of the row length of A with the column length of B to establish your response. Now let's traverse the response matrix, or the rest, the response actually. Oh, by the way, before that, return zero, C plus. All right, so we're here. Now the next thing we need to do is we just need to do the length work. 0 less than A of 0 dot, right? Since we know the column length is equal to the row length of B, all right? And now rest of RC equals to A of R, which is the row, times the length multiplied by B of length times C. I think that's it, actually. So why don't we go ahead and try that code out? Hopefully it works. What did I do? Did I code too fast? Of course I coded too fast. So we got a wrong answer, and why is that? Made a bug over there. Basically, the last element that we didn't actually check. Now that's kind of a silly mistake. Oh, there we go. Now it's happy. And why don't we go ahead and submit it and see what the heck happens? Well, as you can see, it's definitely solvable, better than 9%. I had solved the same exact response like a few seconds ago. So the one optimization, since we are accessing the matrix again and again, what we can do is this, that we know it's 0, right? And then just do temp sum, so that you don't have to constantly access it. And then finally at the end of it, RC, set that to temp sum. I think that should actually give us a little bit better results. It does. It actually cuts it down in half. Now, the question that you probably should be asking is like, you want an optimized solution, right? Like, what's the point of doing all this if you're not even getting a good optimized solution? I'm going to actually do a follow-up video on that to actually get a better solution that actually kind of makes more sense, which is in line with all the solutions that are out there. But just to talk about the runtime complexity of this is, obviously you're going through the entire matrix, which is O sub n, and every time you go through the, you do the dot product, so you're going like n times n. So it's actually like asymptotically approaching m of n squared. So not that great, but definitely solvable. And I'm sure like it's probably a little bit easier solution to sort of let your brain absorb, right? Hope you guys like my video. Definitely like, subscribe, as I'll be posting more videos throughout the week. Thanks, bye.